Hello students and colleagues that have been watching the series on programmable logic controllers presented by the TVET COVID-19 Learner Support Program. I'd like to take the opportunity to thank you for being with us. My name is Vasa Naika and I'm from the TVET College in Pietermaritzburg. And today is a kind of a bit of a sad day for me because it's going to be the last in the series. Hopefully sometime in the future we'll be able to do this again, but for now I'm actually going to show you how we're going to put together all the hard work that you'll be doing so far, and we are going to get to program the complete robot sequence. Just to recap as well, remember I said at the end of these lessons we are going to do the traffic light, but I want to go back to one little thing that we've done in the previous lesson, which was a simple timer circuit. Okay, I've got that up on the board in front of me. Okay, I'm not going to put it back on there now. Remember I said when you actually introduce the timer, which is T1 in this case, all right, we've got Y0.1, which is your motor 1, to actually start the timer. And it was an on-delay timer, so after the predetermined time of 10 seconds, we had the locking switch or the normally closed switch of T1 to actually turn the motor off. We're now going to use this sequence, all right, and it's basically a repetition of this sequence to program a complete robot cycle. So in order to do that, firstly, I'm going to have to assign addresses to my inputs and outputs. Okay, so let's look at the design itself. I'm going to say we'll look at a basic circuit. So design a ladder logic circuit where we have a red light turning on for 15 seconds, a green light turning on for 20 seconds, and then an orange light for 10 seconds, and then the process must repeat itself going back to red, green, orange, etc. All right, what I'm going to first do is actually list my inputs and outputs. Now, I'm going to use normally open contacts. Okay, normally closed contacts. And your output coils. And also your timers. All right? So I can just name this here. Okay, so those are the four basic inputs and outputs that I'm going to use. Let's now first, before we actually get into the actual PLC program, let's identify our inputs and outputs. All right? For my outputs, I'm going to have, obviously, 3 output coils. Okay, which I'm going to call, if you want, red, green, orange. Okay, associated with each of these, since I want each of them to only operate for a certain time, I'm going to have 3 timers, which I'm going to call T1, T2, T3. Okay, and it says T1, your red light must stay on for 15 seconds, so this would be a 15-second timer. T2 must stay on for 20 seconds, so your green light must stay on for 20 seconds. It must then switch to an orange light, and that must stay on for 10 seconds. Okay, so those are my input and output devices. I need to now assign addresses to these, all right? For your output timers, okay, your T1 and your T2 and your T3, those are actually your addresses. The Siemens PLC understands the meaning of T1 and T2 and T3. I will give it symbolic names when we're actually doing the programming. For your output coils, I need addresses for them. Now, what I have already done is I've already connected it up to the PLC and I've given it specific addresses. So for the green light, I called it Q6.1. The red light we've already used, Q6.2, and the orange light was Q6.3. Okay, so these here now, I'm actually going to write it here, will represent all my outputs. For my input, I'm going to have a start button, which is normally open, and I'm going to use the same start button on my panel, and remember the address of this start button was I0.3, so I'm not going to change that. And for my stop button, which is normally closed, I'm going to use the address I0.2, which we used before. I've got an emergency stop. Which is I0.4. Okay, we may use this. We will check just now, which is normally closed. Which I call emergency stop button. Okay. So those are all my inputs and outputs that I'm going to use. Okay, and once again, just to remind you that the program I'm going to write is going to be identical to the program that you would write. The only difference, instead of Q's here, you would most probably use, say, Y001 as an output. Okay? Because in your syllabus, for your inputs you use X's, and for your outputs you use Y's. What I'm going to now do is add all of these to my symbol table and then start the programming sequence. So let's open up the Somatic Manager. Okay, I'm just going to close the simulator. Remember, we're not working with the simulator anymore. Open the Somatic Manager. I'm going to now insert S7 block function, and you can see I've already got FC1. FC1 is actually the program that we used before to run the simulator. The next one comes up at FC2, and I'm going to call this traffic light, TRAFFICLIGHT. Okay, so if I view the details, close this. All right. FC1 is my interlocking circuit. FC2 is my traffic light circuit. When I download my traffic light circuit to the PLC, let's just see if you remember. How does the PLC know which circuits to actually use? Okay. I need to actually define that in OB1, which is my operation block 1. So if I go back to OB1, you can see here that it's still using the interlocking circuit. So if I download the traffic light circuit to the PLC, it will not be used. I've got to change this now. So if I delete that one, and I now insert FC2, which is the traffic light circuit, when I run my PLC, it will run that particular circuit only. Because remember, I said before, in your PLC, you could have 10 to 15 programs that are written by 10 to 15 different people because it has storage memory, just like your computer. But you need to tell it which specific one to use when you want to use it. And in this case, it's the traffic light sequence. All right, I'm then going to close this because I don't need it, because that's FC2. No. Open my traffic light sequence. I'm going to close my symbol editor, don't need it, and options, symbol table. All right. Okay, so before I actually start, I'm going to go again previously like we did before, add all my symbols to the symbol table so it makes the programming easy. So it's going to be red light, and remember the output for my red light, Q6.2. The green light, Q6.1, and the orange light, Q6.3. All right, I've also got my timers, so I'm going to say timer 15 seconds. And now the address for that, I said the PLC understands T1. Okay, then timer 20 seconds. And the PLC knows that as T2. And finally, timer 10 seconds would be T3. So I've now put in my outputs on my symbol table, my timers on my symbol table. I just need to add my start and stop. So I'm going to say start, S-T-A-R-T, is I0.3. Stop is I0.2. Okay, and emergency stop I0.4. Okay, I've got it already. Okay, save my symbol table, and let's go back to writing the program. Okay, bit logic, my start button, stop button, my red contactor, and remember with the red contactor, I need to add a latching circuit. So it'll be normally open switch with the same symbolic address as my coil. For my start button, okay, S-T-A-R-T, you can see if I just type in the word start, my symbol table comes up here, and instead of me trying to remember the address, it actually remembers it for me. I just have to hit enter. Okay, and you see it comes up as I0.3, and that is my actual start address. If I want to go to stop, if I type in ST again, and you can see there's my stop button, click on it, hit enter twice, and the stop and the address comes up. So you can see that initially including your symbol table makes your programming much more easier. I know my red light, if I type in the word red, it actually comes to Q6.2, and it says red light. And this again is going to be Q6.2, which is my latching circuit. So when I press the start button, the red light would come on, the red light would latch itself, and if I press the stop button, the red light should stop. So let's download this to the PLC. Unable to copy FC2, okay, reason being, I'm still on the simulator, stop, close, okay, close. Take it off simulator mode, okay. close this. Do you want to close the session? Yes. No. Okay, now. Okay, I wonder why it's doing that. Let's just see. Ladder, simulators and stop mode, semantic manager. Oh, OP1, download. No, it's not there. There's current application connected to the simulator. Closing it now. Yes. Yes. Close. Okay, we now written the start-stop sequence for the red light. I'm going to download it to the PLC. So download. Okay, it is there. If I press the start button, all right, you see the red light should come on. Okay, now the program says I need to switch it off after 15 seconds. So all I'm going to do, OP1, okay. So all I'm going to do now is include a timer, call it T1, and it's a 15-second timer. So if I say insert network, all right, if I go down to timers, there we go. Remember, it's an on-delay timer. I'm going to call it T1. And my time S5T. Okay, the Siemens timers are called S5 timers, so S5T, and then you put in your time, which is hash 15 seconds. S5T hash 15S. Okay. The other thing is, what is going to start this timer? All right, the moment the red light comes on, I need to start the timer. So I'm going to use the output coil Q6.2 to actually start timer T1. And I now need to switch off the red light once the timer has timed 15 seconds. So remember, from timers previously, I now need to put a normally close contact here, and I call that T1. Okay, if I download this now and put my glasses on, you'll see the timer timing down from 15 seconds, 6, 5, 4, 3, 2, 1, should go off. Okay, so the timer has now timed, the light is off. However, what do I do after this? Okay, I want to turn on the green light. So insert network. Okay, once again, I'm going to have start, stop, latch. And my green light is Q6.1. And Q6.1 will latch itself. I'm just going to remove this for now. Okay, so the timer T1, it will switch off the green light, and it's supposed to switch off the red light, and it's supposed to switch off the green light. Let's see what happens, okay? download. Okay, start the sequence. Okay, it's timing down. 5, 4, 3, 2, 1. Okay, it switched off the red light, but it did not switch on the green light. Now, this is where you actually need to either latch the timer to keep it on, because you will find after it actually timed, it's an on-delay timer, it actually lost its power. It's no more energized, right? So instead of using a normal timer, what we actually do is use what we call a retentive timer. Okay, so it's an on-delay retentive timer. So I'm going to actually remove this timer here and put an on-delay retentive timer, call that T1, and S5T hash, 15 seconds. And now download this. And now let's see what happens. Okay, so my timer is timing. Okay, and you can see after 15 seconds, it retained its power because it is still green, and it turned off light 2. Okay, now just like I've done the timer for T1, I can insert a new network. And say, okay, I want a second timer. What's going to turn my timer on? The green light. Okay, second timer, and this would be Q6.1. It will turn on timer T2, and T2 must time for 20 seconds. So don't forget, it's S5T hash, 20 seconds. And now I need it to turn off the green light. So remember, just like we did timers initially, I'm going to put a normally closed contactor here, and I'm going to say T2. So what would happen is after 20 seconds, this timer would now energize and turn off the green light. Okay? Remember, timer T1 is still energized, so I actually want to reset it. Okay? What can I use to reset it? All right? I could actually use T2 to reset T1. Okay? Or I could use the orange light, which is the next light, to reset the previous timer. Okay? So I'm going to put T2 here for now. Okay, and that will reset timer T1. To continue with the program, okay, first let's download this. Okay, let's see what happens. You can see timer T2 is now timing 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Off. Okay, so the green light is off. I'm going to actually use Q6.2 here to reset T2, which is also a retentive timer. If I press my start button again, let's have a look at my sequence thus far. It should show me the red light staying on for 15 seconds via T1, then the green light coming on for 20 seconds because of T2, Okay, so let's start the sequence again. Press the start button. Okay, my red light should come on for 15 seconds. Is it timing? Is it the right circuit? Okay, the green light is now timing down. Okay, orange light is now timing down. Okay, but remember now, we said that the process has to be repetitive. That means I don't have to now go and repress my start button for the sequence to continue. Remember, we discussed earlier on the OR function, where we said either switch A can start a motor or energize a contactor, or switch B. And we said those switches have to be in parallel. So I know that after timer T3, I can restart the sequence. So if I go back to line 1 of my programming, I can say, okay, over here, let me put the OR function and put in a switch and say, either the start button can start the red light, or T3 can start the red light. And you'll find now the process would actually repeat itself. Okay, let's press the start button. And now the sequence should actually repeat itself because I've asked T3 to start the red sequence again, or the red light again. And it should be timing. Okay, I can watch T3, timing. 3, 2, 1, 0. And the red light turns on again. So the sequence will now repeat itself, unless I, of course, press the stop button, all right, or the emergency stop. I know there's quite a bit that we've done in the short space of time. Normally, what I've actually attempted to teach you now would take me at least a week and a half with my students. So I must once again apologize for going quite fast through everything, but I try to cram in as much as you can. May God bless you all, my people. I think the best way to do it is to sanitize. As I always say, keep safe, and don't forget your 2 best friends. Currently, these are my 2 best friends. So look after yourself, look after your loved ones. Keep your mask on, stay smart, and stay apart. Thank you.